Dear students, today's lecture is a short lecture on how to remember formulas of differentiation. We know if we want to derive some function, find the derivative of something, then we need to remember the formulas of differentiation. Sometimes it is hard to understand how to remember, but today's lecture will help you how to easily remember the formulas of derivative. So I have written function on the left hand side and its derivative, its differentiation on the right hand side. Suppose the function is our fx, its derivative is f dash x. Now basically the simplest of the function is a constant. Suppose I want to find the derivative of 1, 10, 120, 99, 100, 1 by 2, 3 by 2, any number. So the first formula is for a constant, let us say k. It is any number, real number, 1 by 2, 3 by 2, 1, 0, 99. So if you want to remember its derivative, it is simple, 0. So the constant has derivative 0. Now the second function that obviously comes in our mind is x, then x square, then x cube, x raised to 4, x raised to 99 maybe, x raised to 100. So that function, let us say in general it is x raised to n. If n is equal to 1, then the function is x. If n is equal to 2, then the function is x square. If n is equal to 3, then the function is x cube. And you can write real numbers also, 1 by 2, 3 by 2, 3 by 4, 5 by 4 also, x raised to 3 by 2 and all. So the n belongs to R, where R is set of real numbers. So for x raised to n, its derivative is n x raised to n minus 1. N x raised to n minus 1. Now let me give you an example here. Suppose we want to find out the derivative of x square. So here from the formula you can understand n is 2. So the derivative of x square is 2 x raised to 2 minus 1, which is equal to 2 minus 1 is 1. So it is 2x. The derivative of x square is 2x. In the similar way, you can find the derivative of x cube is 3x raised to, now it is 3 minus 1. So I will directly write 2. The derivative of x cube is 3x square. And in the similar manner, for any n belongs to R, you can find the derivative of x raised to n, that is n x raised to n minus 1. Now let us go into some deep formulas, like if you have log x, our function, let us say it is log x, the derivative of log x is 1 upon x. Constant has derivative 0, x raised to n has derivative n, x raised to n minus 1, log x has derivative 1 upon x. Next function will be e raised to x. This is the only function whose derivative remains same, that is e raised to x has derivative e raised to x only. So you need not have to remember e raised to x has derivative e raised to x. Then the function a raised to x. Now why I have taken e raised to x and a raised to x differently? Because e is also a number and a is also a number. But what happens when you find the derivative of a raised to x? It is a raised to x log a, and in case of e raised to x, it is e raised to x, because log e will be there and log e is 1. If you are taking it to the base e, then log e is 1. Okay, so e raised to x has derivative e raised to x, a raised to x has derivative a raised to x log a. Now here the example of a raised to x, suppose I have 5 raised to x, its derivative by the formula, it will be 5 raised to x log 5. Similarly, you can find the derivative of 3 raised to x as 3 raised to x log 3. Now coming to the trigonometric functions, the derivative of sine x, cos x and all, we will write down first all the functions. Let us say here I have write sine x, its derivative I will tell you later. Then the other function is cos x, then sine upon cos will be tan x. In the similar way you will have sec x, then cosec x, then cot x. So on the left hand side I have mentioned all the formulas, trigonometric functions, sin x, cos x, tan x, sec x, cosec x and cot x. Now try to remember them as pair. So first pair will be of sin x and cos x. The next pair will be of tan x and sec x. The third pair will be of cosec x and cot x. So if you remember it in pair, then it is easy for you to remember the derivative of them. So sin x and cos x are in pair. The derivative of sin x is cos x. The derivative of sin x is cos x. The derivative of cos x, let us write down sin x. It is not directly sin x, but we will understand it later. Okay? The derivative of sin x, cos x, sin x. So they are in pair. That's why I have written directly sin's derivative cos, cos derivative sin. There are positive negative signs also. I will tell you later how to write down them. Again, so for the pair sin x cos x, write down sin x derivative cos, cos derivative sin. Now for the pair tan and sec. In tan you will find sec, and in the formula of derivative of sec you will find tan. So the derivative of tan, write down sec square x. Okay, so the derivative of tan x is sec square x. Now the derivative of sec x is sec x tan x. So the derivative of tan x is sec square x, derivative of sec x is sec x tan x. Tan x involves sec x involves tan x. So that's why I have tell you that remember it in pair. Now one no tan x, if you write down 1 upon tan x, so just like tan x it is cot x, just like sec x it is cosec x. So the pair tan and sec goes same with cot and sec. The derivative of tan involves sec, so similarly the derivative of cot will involve cosec, and the formula also remains the same. See, check this one. Tan has derivative sec square x. Similarly cot x will have the derivative, its pair is with cosec x, so its derivative will be cos square x. This is the simplest way to remember them. Tan sec square x, cot cosec square x. Now the derivative of sec x is sec x tan x. What will be the derivative of cosec x? In the similar manner like sec x, it will involve its pair also. So cosec x into cot x. So the derivative of tan is sec square, similarly cot is cosec square. The derivative of sec x is sec x tan x, cosec x is cosec x cot x. But they are not complete here. Now whenever you are in these trigonometric functions, you will find c, that is cos, starting from c, cos x. Again starting from c is cosec x and cot x. So these three, cos x, cosec x, cot x, they are starting from alphabet c. So their derivative comes with negative sign. So the derivative of cos x is minus sin x. The derivative of cosec x will be minus cosec x cot x. And the derivative of cot x will be minus cosec square x. So these are the easiest ways to remember these formulas. Tan pairing with sec. Tan's derivative involves sec square x. Similarly, cot's derivative will involve cosec square x. Sec x has derivative sec x tan x. Similarly, cosec x derivative with his pair cosec x cot x. Again, the trigonometric functions starting with alphabet c are cos x, cosec x, cot x. So write down negative sign ahead of their derivative. That is minus sin x, minus cosec x, cot x, minus cos square x. So the formulas are easy to remember, and you can take screenshot of this formula for your reference. Thank you, friends.